Hello viewers, welcome back to our channel Career Prep. In this video, we are going to discuss the concept of digital root and also solve a few simplification problems using the digital root method. This concept is very useful for saving time and effort in certain long calculation questions, both in quant section as well as in data interpretation. Since time management is most important in competitive exams, learn well the concept of digital roots and its application to solve simplification problems. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Let's understand the concept of digital sum and digital root. The digital sum of a positive integer is found by summing the digits of the integer. This means that if we add all the digits in a number, we'll get the digital sum of the number. Now, if the resulting digital sum is a single digit, then that digit itself is the digital root. Instead, if the resulting digital sum contains two or more digits, then those digits are summed and the process is repeated till a single digit is obtained. Thus, digital root is a single digit number. Digital root is also called repeated digital sum. Since digital root is a single digit number, digital sum is repeated till we obtain a single digit digital root. For example, the digital sum of 43 is 4 plus 3, which is 7. Here, 7 is a single digit number. So, 7 itself is the digital root of 43. The digital sum of 347 is 3 plus 4 plus 7, which is 14. Now here 14 is a two-digit number. So you have to find the digital sum of 14, which is 1 plus 4, that is 5. Now 5 is a single digit number. So 5 is the digital root. So 5 is the digital root of 347. Let's learn a few shortcuts to find the digital root. The digital root of any number containing only nines is 9. Look at these numbers 99, 999, 9999. The digital root of 99 is 9 because 9 plus 9 is 18 and 1 plus 8 is 9. The digital root of 999 is 9 because 9 plus 9 plus 9 is 27 and 2 plus 7 is 9. The digital root of 9999 is 9 because 9 plus 9 plus 9 plus 9 is 36 and 3 plus 6 is 9. So the digital root of any number containing only nines is 9. If there is one or more nines in a number, simply ignore them and add the remaining digits. Also, look out for digits that you can quickly add to 9. Ignore those digits and add the remaining digits. For example, look at the number 19. The number 19 has a 9 in it. So you can ignore this 9. You're left with 1. So 1 is the digital root of 19. Look at this number 998. There are two nines which you can ignore. You're left with 8. So 8 is the digital root of 998. Look at the number 3198. You can ignore this 9. Also 1 plus 8 is 9. So you can ignore these two digits 1 and 8. So you are left with 3. So 3 is the digital root of 3198. Look at the number 7781. Here 8 plus 1 is 9. So you can ignore these two digits. You are left with 7 and 7. 7 plus 7 is 14 and 1 plus 4 is 5. So 5 is the digital root of 7781. Let's understand a few properties of digital root. Digital root of any number will be from 1 to 9 since digital root is a single digit number. When you multiply any number with 9, the digital root will always be 9. For example, when you multiply 7 with 9, you get 63 and 6 plus 3 is 9. When you multiply 13 with 9, you get 117 and 1 plus 1 plus 7 is 9. If the digital sum of a number is 9, then we can eliminate the 9 straight away and the digital root becomes 0. For example, when in this number 63, when you add 6 plus 3, you will get 9. So you can eliminate 9 straight away and the digital root becomes 0. So 9 is equivalent to 0. So 0 is the digital root of 63. But on multiplication, if 9 is got as the digital root, then it is not equal to 0. For example, 21 multiplied by 3. 2 plus 1 is 3. So 3 multiplied by 3 is 9. Here, the value of 9, you have to take the value as 9, not 0. So only when you add the digits and get the result as 9, then you can consider the digital root as 0. But when you multiply and get 9, then 9 itself is the digital root, not 0. When we add an extra 9 to a number, it does not change the digital root of that number. Look at the number 527. Here 2 and 7 add up to 9, so you can ignore these two digits. So the digital root of 527 is 5. Now if we add an extra 9 to this number 527, it becomes 5279. Again 2 and 7 add up to 9, so you can ignore these two digits. You can cancel out the 9. So you're left with 5. The digital root of 5279 is 5. So even when you add an extra 9 to the number, it does not change the digital root of that number. When we divide any number by 9, the digital root of that number will be the remainder. For example, when you divide 13 by 9, the remainder is 4, which is the same as the digital root of the numerator 13, because 1 plus 3 is 4. Similarly, when you divide 47 by 9, the remainder is 2, which again is the same as the digital root of the numerator 47, because 4 plus 7 is 11 and 1 plus 1 is 2. So when you have a fraction with 9 as the denominator, the digital root of the fraction is the digital root of the numerator. The digital root of any perfect square will be one of the four digits 1, 4, 7 or 9 only. For example, 8 squared is equal to 64 and 6 plus 4 is 10 and 1 plus 0 is 1. Now 7 squared is 49. You can ignore the 9 here. So the digital root of 7 squared is 4. 4 squared is equal to 16 and 1 plus 6 is 7. So the digital root of 4 squared is 7. 6 squared is equal to 36 and 3 plus 6 is 9. So the digital root of a perfect square will be either 1, 4, 7 or 9. Digital root of a perfect cube is 1, 8 or 9. For example, 4 cubed is 64 and 6 plus 4 is 10 and 1 plus 0 is 1. So the digital root of 4 cubed is 1. 5 cubed is 125 and 1 plus 2 plus 5 is 8. So the digital Root of 5 cubed is 8. 6 cubed is 216 and 2 plus 1 plus 6 is 9. So 9 is the digital root of 6 cubed. So the digital root of a perfect cube is either 1, 8 or 9. While solving problems, if you get a negative digital root, just add 9 to it and the result will be the actual digital root. For example, find the digital root of 2134 minus 200. Here 2 plus 3 plus 4 is 9. So you can ignore these three digits. You are left with 1. So 1 minus 2 plus 0 is 2. So 1 minus 2 is minus 1. So you got a negative digital root here. So just add 9 to minus 1. You will get 8. So 8 is the digital root of this expression. You can neglect the decimal point and percentage sign in a question. Simply proceed as if there were no such signs. This is because in a decimal number, the denominator is powers of 2 and so the digital root of the denominator will be 1. And in case of a percentage, the denominator will be 100 and so the digital root of the denominator will be 1. So in both the cases of the decimal point and percentage sign, the digital root will be 1. For example, 12.832 can be written as 12,832 divided by 1000. Here the digital root of 1000 is 1. So digital root of 12.832 is nothing but the digital root of the numerator 12832. Here 1 plus 8 is 9, so you can neglect these two digits. So 2 plus 3 plus 2 is 7. So 7 is the digital root of 12.832. Now 17% can be written as 17 divided by 100. Here the digital root of 100 is 1. So the digital root of 17% is nothing but the digital root of the numerator 17, which is 1 plus 7, which is 8. So 8 is the digital root of 17%. For addition, subtraction and multiplication problems, just find the digital root of the given numbers and proceed with the mathematical operations as given in the question to get the digital root of the answer. For example, 2387 minus 123 plus 980 is equal to how much? First, find the digital root of the numbers and add or subtract as given in the question to get the digital root of the answer. So, in 2387, 2 plus 7 is 9. You can ignore those two digits. 3 plus 8 is 11 and 1 plus 1 is 2. Minus 1 plus 2 plus 3 is 6. Plus in 980 you can ignore the 9. So 8 plus 0 is 8. So you get 2 minus 6 plus 8, which is 4. So 4 is the digital root of the answer. Look at another example. 58 multiplied by 96 multiplied by 62 is equal to how much? Find the digital root of the numbers and multiply to get the digital root of the answer. So in 58, 5 plus 8 is 13 and 1 plus 3 is 4. In 96, you can ignore the 9 and you're left with 6 here. And 6 plus 2 is 8. So 4 multiplied by 6 multiplied by 8 is 192. Again, you can ignore the 9 here. 1 plus 2 is 3. So 3 is the digital root of the answer. Now finally, check the digital root of the answer obtained with the digital root of the given options. If it matches, then that option is most likely the correct answer option. The mathematical procedure involved in division is slightly different. Here, the digital root of the numerator and denominator has to be found separately. Now we know that if the digital root of the denominator is 1, then the digital root of the fraction is nothing but the digital root of the numerator. So the main idea while finding the digital root in division problems should be to make the digital root of the denominator as 1. So now let's understand how to make the digital root of the denominator as 1. When the digital root of the denominator is 2, simply multiply both the numerator and the denominator by 5. Now the digital root of the denominator becomes 1 because 2 multiplied by 5 is 10 and 1 plus 0 is 1. So the digital root of the denominator becomes 1. Now when the digital root of the denominator is 4, simply multiply the numerator and the denominator by 7. Now the digital root of the denominator becomes 1 because 4 multiplied by 7 is 28 and 2 plus 8 is 10 and 1 plus 0 is 1. So 1 is the digital root of the denominator. When the digital root of the denominator is 5, simply multiply the numerator and denominator by 2. Now the digital root of the denominator becomes 1 because 5 multiplied by 2 is 10 and 1 plus 0 is 1. So 1 is the digital root of the denominator. When the digital root of the denominator is 7, simply multiply the numerator and denominator by 4. Now the digital root of the denominator becomes 1 because 7 multiplied by 4 is 28 and 2 plus 8 is 10 and 1 plus 0 is 1. So 1 is the digital root of the denominator. When the digital root of the denominator is 8, simply multiply the numerator and the denominator by 8. Now the digital root of the denominator becomes 1 because 8 multiplied by 8 is 64 and 6 plus 4 is 10 and 1 plus 0 is 1. So 1 is the digital root of the denominator. When the digital root of the denominator is either 3 or 6 or 9 or 0, then if it is divisible, then divide the digital root of the numerator by them respectively to get the digital root of the fraction. If not, then the digital root method cannot be applied to solve the division problem. Now let's understand how the digital root method works for solving a mathematical expression or equation. In any mathematical expression or equation, you can simply find the digital root of the given numbers and continue the mathematical operation as given in the question. Finally, check the digital root thus obtained to the digital root of the given options. If it matches, then that is the most likely correct option. This property is used to solve simplification problems quickly and easily. The digital root method eliminates the otherwise lengthy calculations in the simplification problems. Let's solve a few simplification problems using the digital root method so that you can be perfect with the concept. 9643 minus 7750 plus question mark is equal to 4990. Here you are given 4 answer options and you have to find out which of these answer options can replace the question mark in the given equation. So now let the question mark be x. So we have 9643 minus 7750 plus x is equal to 4990. Let's find the digital root of these numbers. So here 9 can be ignored. 6 plus 3 is 9. So those two digits also can be ignored. So you're left with 4 here. Minus 7 plus 7 is 14. 14 plus 5 is 19. And 1 plus 9 is 10. And 1 plus 0 is 1. So digital root of this number is 1. Here you can ignore 9 and 9. So 4 plus 0 is 4. So the digital root of this number is 4. So now we have 4 minus 1 plus x is equal to 4. So x is equal to 4 minus 3, which is 1. So x is 1. So the digital root of the number that comes in place of the question mark is 1. Check which of the answer options has 1 as the digital root. Now answer option A is 3089. You can ignore the 9 here. 3 plus 8 is 11 and 1 plus 1 is 2. So 2 is the digital root here. Option B is 3097. Ignore the 9 here. 3 plus 7 is 10 and 1 plus 0 is 1. So the digital root is 1 here. Option C is 3090. Ignore the 9 here. So the digital root is 3 here. Option D is 4010. 4 plus 1 is 5. So 5 is the digital root of this number. So when you look at these options, you'll see that option B has the number with the digital root as 1. So the correct answer is option B, 3097. 764 multiplied by question mark divided by 250 is equal to 382. Now you are given 4 answer options and you have to find out which of these answer options can replace the question mark in the given equation. Now let the question mark be x. So you have 764 multiplied by x divided by 250 is equal to 382. Now find the digital root of the numbers in the equation. So 7 plus 6 is 13, 13 plus 4 is 17 and 1 plus 7 is 8 and 8 multiplied by x is 8x divided by 2 plus 5 is 7. So the digital root here is 7. 3 plus 8 is 11. 11 plus 2 is 13 and 1 plus 3 is 4. So the digital root of 382 is 4. So now you have 8x divided by 7 is equal to 4 or 8x by 7 is equal to 4. So 8x is equal to 7 multiplied by 4, which is 28, and 2 plus 8 is 1. 8x is 1, so x is 1 by 8. Now you have 8 in the denominator of this fraction. So to make the denominator of this fraction as 1, you have to multiply both the numerator and denominator with 8. So now you have x is equal to 1 multiplied by 8 divided by 8 multiplied by 8. Now 8 multiplied by 8 in the denominator is equal to 64. 6 plus 4 is 10 and 1 plus 0 is 1. So the denominator, the digital root in the denominator becomes 1. Now in the numerator you have 1 multiplied by 8, which is 8. So x is equal to 8. This means that the digital root of the number that comes in place of the question mark is 8. Now check which of the answer options has 8 as the digital root. Option A is 115 and 1 plus 1 plus 5 is 7. Option B is 145. 4 plus 5 is 9. You can ignore those two digits. So the digital root here is 1. Option C is 135. 1 plus 3 plus 5 is 9, which is nothing but 0. So the digital root here is 0. Option D is 125. 1 plus 2 plus 5 is 8. So the digital root is 8 here. So when you look at these options, you'll see that the number in option D has a digital root as 8. So the correct answer is option D, 125. 38 squared plus 63 squared plus question mark squared is equal to 6089. You are given 4 answer options and you have to find out which of these options can replace the question mark in the given equation. So let question mark be x. So now you have 38 squared plus 63 squared plus x squared is equal to 6089. Find the digital root of the numbers in the given equation. 3 plus 8 is 11 and 1 plus 1 is 2. So 2 squared is 4. 6 plus 3 is 9, which is nothing but 0. So 0 squared is 0. 6089, you can neglect the 9 here. 6 plus 8 is 14 and 1 plus 4 is 5. So now you have 4 plus x squared is equal to 5, or x squared is equal to 5 minus 4, which is 1. So x squared is 1. So now you have to find the answer option whose digital root when squared is 1. So answer option A has 26 as a number and 2 plus 6 is 8. So now you have to square the digital root, that is 8 squared. 8 squared is 64 and 6 plus 4 is 10 and 1 plus 0 is 1. Similarly, option B 24. 2 plus 4 is 6 and 6 squared is 36. 6 plus 3 is 9, which is nothing but 0. Option C is 23. 2 plus 3 is 5 and 5 squared is 25 and 2 plus 5 is 7. Option D is 31. 3 plus 1 is 4 and 4 squared is 16 and 1 plus 6 is 7. So when you look at all these options, you'll see that option A has the digital root which when squared gives 1 as the answer. So the correct answer is option A, 26. 12.25 multiplied by 7.2 plus 84.33 is equal to how much? You are given 4 answer options and you have to find out which of these answer options can replace the question mark in the given equation. So let question mark be x. Here you can ignore the decimal points in these numbers. So now you have 1225 multiplied by 72 plus 8433 is equal to x. Now find the digital root of these numbers. 2 plus 2 is 4, 4 plus 5 is 9. You can ignore these 3 digits. So the digital root here is 1. 7 plus 2 is 9 and 9 is nothing but 0. Here 8 plus 4 is 12, 12 plus 3 is 15, 15 plus 3 is 18 and 1 plus 8 is 9, which is nothing but 0. So now you have 1 multiplied by 0 plus 0 is equal to x. So x is equal to 0. This means you have to find the answer option whose digital root is 0. Answer option A is 182.51. Ignoring the decimal point here, you get the number 18251. 1 plus 2 plus 5 plus 1 is 9. So you can ignore all these 4 digits. So the digital root here is 8. Option B is 177.44. Ignoring the decimal point here, you get the number 17744. Here 1 plus 4 plus 4 is 9. So you can ignore these 3 digits. 7 plus 7 is 14 and 1 plus 4 is 5. So 5 is the digital root here. Option C is 174.34. Ignoring the decimal point, you get the number 17434. So 1 plus 4 is 9. You can ignore these three digits. 7 plus 3 is 10 and 1 plus 0 is 1. So the digital root here is 1. Option D is 172.53. Ignoring the decimal point, you get the number 17253. Here 7 plus 2 is 9. You can ignore these two digits. And 1 plus 5 plus 3 is 9. So you can ignore these three digits also. So here 0 is the digital root. So when you look at all these options, you will notice that option D has a number whose digital root is 0. So the correct answer is option D, 172.53. 12% of 555 plus 15% of 666 is equal to how much? You are given four answer options and you have to find out which of these answer options can replace the question mark in the given equation. So let question mark be X. Also here you can ignore the percentage signs and then replace off with multiplication sign. So now you have 12 multiplied by 555 plus 15 multiplied by 666 is equal to X. Now find the digital root of these numbers. 1 plus 2 is 3 multiplied by 5 plus 5 plus 5 is 15 and 1 plus 5 is 6. 1 plus 5 is 6. So the digital root of 15 is 6. 6 plus 6 plus 6 is 18 and 1 plus 8 is 9, which is nothing but 0. So the digital root of 666 is 0. So now you have 3 multiplied by 6 plus 6 multiplied by 0 is equal to X. 3 multiplied by 6 is 18 and 1 plus 8 is 9, which is nothing but 0. So X is equal to 0. This means you have to find the answer option whose digital root is 0. Answer option A is 166.5. Ignoring the decimal point, you have the number 1665. 1 plus 6 is 7, 7 plus 6 is 13, 13 plus 5 is 18 and 1 plus 8 is 9, which is nothing but 0. Option B is 167.5. Ignoring the decimal point, you have the number 1675. 1 plus 6 is 7, 7 plus 7 is 14, 14 plus 5 is 19 and 1 plus 9 is 10 and 1 plus 0 is 1. So the digital root here is 1. Option C is 168.5. Ignoring the decimal point, you have the number 1685. 1 plus 6 is 7, 7 plus 8 is 15, 15 plus 5 is 20 and 2 plus 0 is 2. So 2 is the digital root here. Option D is 169.5. Ignoring the decimal point, you have the number 1695. Here you can ignore the 9. 1 plus 6 is 7, 7 plus 5 is 12 and 1 plus 2 is 3. So 3 is the digital root here. So when you observe all these options, you will see that option A has a number whose digital root is 0. So the correct answer is option A, 166.5. 40% of 265 plus 35% of 180 is equal to 50% of what? Now you are given four answer options and you have to find out which of these answer options can replace the question mark in the given equation. Let question mark be X. Here you can neglect the percentage signs here. Also replace off with multiplication sign. So now you have 40 multiplied by 265 plus 35 multiplied by 180 is equal to 50x. Now find the digital root of all these numbers. 4 plus 0 is 4. So the digital root here is 4. 2 plus 6 is 8. 8 plus 5 is 13. And 1 plus 3 is 4. So the digital root here is 4. 3 plus 5 is 8. The digital root here is 8. 1 plus 8 is 9. You can ignore these two digits. So the digital root here is 0. 5 plus 0 is 5. So the digital root here is 5. So now you have 4 multiplied by 4 plus 8 multiplied by 0 is equal to 5x. 8 multiplied by 0 is 0. So you can neglect that. 4 multiplied by 4 is 16 and 1 plus 6 is 7. So 7 is equal to 5x or x is equal to 7 by 5. Now the digital root in the denominator here is 5. So to make the digital root of the denominator as 1, multiply both the numerator and denominator with 2. So now you have x is equal to 7 multiplied by 2 divided by 5 multiplied by 2. So in the denominator 5 multiplied by 2 is 10 and 1 plus 0 is 1. So the digital root of the denominator now becomes 1. The digital root of the numerator is 7 multiplied by 2 is 14 and 1 plus 4 is 5. So the digital root of the numerator is 5. So x is equal to 5. This means you have to find the answer option whose digital root is 5. Answer option A is 338. 3 plus 3 is 6, 6 plus 8 is 14 and 1 plus 4 is 5. So the digital root here is 5. Option B is 84.5. Ignoring the decimal point you get the number 845. Here 4 plus 5 is 9, you can ignore those two digits. So the digital root here is 8. Option C is 253.5. Ignoring the decimal point, you have the number 2535. 2 plus 5 is 7, 7 plus 3 is 10, 10 plus 5 is 15 and 1 plus 5 is 6. So 6 is the digital root here. Option D is 169. You can ignore the 9 here. 1 plus 6 is 7. So 7 is the digital root here. When you look at all these options, you'll see that option A has the digital root as 5. So the correct answer is option A, 338. 2197 divided by 13 plus 242 divided by 11 plus 1024 divided by 8 is equal to how much? You are given 4 answer options and you have to find out which of these answer options can replace the question mark in the given equation. So let question mark be x. Now let's find the digital root of these fractions. To do that, you have to find the digital root of the numerator and the denominator separately. So in the numerator 2197, 2 plus 7 is 9. You can ignore those two digits. You can ignore 9 also. So the digital root of the numerator here is 1. And 1 plus 3 in the denominator is 4. So 4 is the digital root of the denominator here. 2 plus 4 plus 2 is 8. So 8 is the digital root of the numerator here. 1 plus 1 is 2. So 2 is the digital root of the denominator here. 1 plus 0 is 1. 1 plus 2 is 3. 3 plus 4 is 7. So 7 is the digital root of the numerator in this fraction. And you have 8 as the digital root of the denominator here. So now you have 1 by 4 plus 8 by 2 plus 7 by 8 is equal to x. Now you have 4, 2 and 8 as denominators here. So making the denominators as 1, we get 1 multiplied by 7 by 4 multiplied by 7 plus 8 multiplied by 5 by 2 multiplied by 5 plus 7 multiplied by 8 by 8 multiplied by 8 is equal to x. Now in the denominator here, 4 plus 7 is 28 and 2 plus 8 is 10 and 1 plus 0 is 1. So the digital root of the denominator of this fraction is 1. 1 multiplied by 7 is 7. So the digital root of the numerator of this fraction is 7. Here 2 multiplied by 5 is 10 and 1 plus 0 is 1. So the digital root of the denominator here is 1. 8 multiplied by 5 is 40 and 4 plus 0 is 4. So the digital root of the numerator here is 4. 8 multiplied by 8 is 64 and 6 plus 4 is 10 and 1 plus 0 is 1. So the digital root of the denominator here is 1. 7 multiplied by 8 is 56 and 5 plus 6 is 11 and 1 plus 1 is 2. So 2 is the digital root of the numerator here. So now you have x is equal to 7 plus 4 plus 2, which is 13, and 1 plus 3 is 4. So x is equal to 4. This means you have to find the answer option whose digital root is 4. So answer option A is 312. 3 plus 1 is 4, 4 plus 2 is 6. So 6 is the digital root here. Option B is 319. You can ignore the 9 here. 3 plus 1 is 4. So 4 is the digital root here. Option C is 280. 2 plus 8 is 10 and 1 plus 0 is 1. So the digital root is 1 here. Option D is 282. 2 plus 8 is 10, 10 plus 2 is 12 and 1 plus 2 is 3. So the digital root here is 3. When you observe all these options, you'll notice that option B has the digital root as 4. So the correct answer is option B, 319. 880 divided by 25% of 220 is equal to question mark squared. You are given 4 answer options here and you have to find out which of these answer options can replace the question mark in the given equation. So let question mark be x. You can ignore the percentage sign here. Also replace off with multiplication sign. So now you have 880 divided by 25 multiplied by 220 is equal to x squared. Now find the digital root of the numerator and the digital root of the denominator separately in this fraction. So 8 plus 8 is 16 and 1 plus 6 is 7. So 7 is the digital root of the numerator. 2 plus 5 is 7 multiplied by 2 plus 2 is 4. 7 multiplied by 4 is 28 and 2 plus 8 is 10 and 1 plus 0 is 1. So the digital root of the denominator is 1. So now you have 7 is equal to x squared. This means you have to find the answer option whose digital root when squared is 7. Option A is 21. So 2 plus 1 is 3 and 3 squared is 9. So 9 is the digital root here. Option B is 19. You can ignore the 9 here. So you get 1 as the digital root and 1 squared is 1. So 1 is the digital root here. Option C is 8. 8 squared is 64 and 6 plus 4 is 10 and 1 plus 0 is 1. So 1 is the digital root here. Option D is 4 and 4 squared is 16 and 1 plus 6 is 7. So 7 is the digital root here. So when you observe all these options, you will see that Option D has the digital root which when squared is 7. So the correct answer is option D, 4. 17.5% of 754 is equal to question mark raised to the power of half plus 51.31 plus 51.64. You're given 4 answer options and you have to find out which of these answer options can replace the question mark in the given equation. So let question mark be x. You can ignore the percentage sign here. Now x raised to the power half means square root of x. In these two numbers you can ignore the decimal point. So now you have 175 multiplied by 754 is equal to square root of x plus 5131 plus 5164. Now find the digital root of all these numbers. 1 plus 7 is 8, 8 plus 5 is 13 and 1 plus 3 is 4. So 4 is the digital root here. Here 5 plus 4 is 9, you can ignore these two digits. So the digital root here is 7. Here 5 plus 1 plus 3 is 9. So the digital root here is 1 since you can ignore these three digits. Here 5 plus 4 is 9. You can ignore these two digits. So 1 plus 6 is 7 and 7 is the digital root here. So now you have 4 multiplied by 7 is equal to square root of x plus 1 plus 7. 4 multiplied by 7 is 28 and 2 plus 8 is 10 and 1 plus 0 is 1. So the digital root here is 1. 1 plus 7 is 8. So now you have 1 is equal to root of x plus 8. Now square root of x is equal to 1 minus 8 which is minus 7. So square root of x is minus 7. Since you cannot have a negative digital root, add 9 to this number. So square root of x is equal to 9 minus 7 which is 2. Square root of x is 2. Squaring on both sides of the equation you get x is equal to 4. This means you have to find the answer option whose digital root is 4. Option A is 841. 8 plus 1 is 9. You can ignore those two digits. So 4 is the digital root here. Option B is 324. 3 plus 2 plus 4 is 9 which is 0. So the digital root here is 0. Option C is 676. 6 plus 7 is 13. 13 plus 6 is 19 and 1 plus 9 is 10 and 1 plus 0 is 1. So the digital root here is 1. Option D is 900. 9 plus 0 is 9. So which is nothing but 0. So 0 is the digital root here. When you observe all these options, you'll notice that option A has a number whose digital root is 4. So the correct answer is option A, 841. 65% of 400 plus square root of question mark is equal to 44% of 800 minus 12% of 400. You are given 4 answer options and you have to select which of these options can replace the question mark in the given equation. Now let question mark be x. Also you can ignore the percentage signs in these numbers. Also replace off with multiplication sign. So now you have 65 multiplied by 400 plus square root of x is equal to 44 multiplied by 800 minus 12 multiplied by 400. Now find the digital root of these numbers. 6 plus 5 is 11 and 1 plus 1 is 2. So 2 is the digital root here. 4 is the digital root here. 4 plus 4 is 8. So 8 is the digital root here. 8 is the digital root of 800. 1 plus 2 is 3, so 3 is the digital root here. And 4 is the digital root here. So now you have 2 multiplied by 4 plus square root of x is equal to 8 multiplied by 8 minus 3 multiplied by 4. 2 multiplied by 4 is 8. 8 multiplied by 8 is 64, and 6 plus 4 is 10, and 1 plus 0 is 1. So the digital root here is 1, minus 3 multiplied by 4 is 12, and 1 plus 2 is 3. So the digital root here is 3. So now you have 8 plus square root of x is equal to 1 minus 3. 1 minus 3 is minus 2. So now you have 8 plus square root of x is equal to minus 2. Shift 8 to the right hand side, it will become minus 8. So now you have square root of x is equal to minus 2 minus 8. So square root of x is equal to minus 10. 1 plus 0 is 1. So square root of x is minus 1. Squaring both sides, you will get x is equal to 1. This means you have to find the answer option whose digital root is 1. Answer option A is 1936. You can ignore the 9. 3 plus 6 is 9, so you can ignore these two digits. So the digital root here is 1. Option B is 44. 4 plus 4 is 8. 8 is the digital root here. Option C is 2115. 2 plus 1 plus 1 plus 5 is 9, which is nothing but 0. 0 is the digital root here. Option D is 45. 4 plus 5 is 9, which is nothing but 0. So 0 is the digital root here. When you observe all these options, you'll notice that option A has a number whose digital root is 1. So the correct answer is option A, 1936. Viewers, please go through this video till you have understood the concept well. Also try to solve as many simplification problems as possible using the digital root method. This will help in increasing your speed as well as in your understanding of the concept clearly. If you have liked this video, please like, subscribe and share this video. Thank you.